Hi, and welcome back to the Intro to AI module of the AI Engineer Bootcamp. In this section of the course, we will start talking about the different types of machine learning. But first, I would like to ask you a favor. I would be really grateful if you could go to the course dashboard, which is very easy to do, and click on Leave a Rating. This will mean a lot to me and will help other students know that this course is worth taking. The reason I'm asking you to do this now is that this is a large course, and most people do not complete all the lessons in one sitting, eventually forgetting to leave a rating. So, please do it now. It should only take a couple of seconds, and it will really validate our efforts. Thank you so much for this. Okay, having said that, let's continue with the Intro to AI module. Okay, great. So far, we've explored AI basics, its history, and the distinctions between weak and strong AI. You already learned about the key ingredient to building AI, high-quality, abundant data. We're making excellent progress. Next, we should explore machine learning, the AI subfield pivotal to its recent success. The idea of ML is fascinating because it boils down to designing a system capable of learning and improving through a trial and error process. Consider building a machine learning model similar to a student taught by a teacher. In this case, the machine learning model is the student, and the data scientist is the teacher. The teacher's role is to help the student learn how to solve problems. To do this well, the teacher must provide the student with many suitable learning materials, which in the world of machine learning means providing a lot of good data. With sufficient information, the student carefully studies and absorbs the training materials. Similarly, the machine learning algorithm learns to recognize patterns in the fed training data. The aim is to prepare students to succeed on their final exam, featuring unfamiliar questions that test previously covered material. In the ML model's case, we aim to teach it how to solve a particular problem with data it has never seen. The more up-to-date and better the training data, the better the model can solve new, challenging problems it has never seen. Without adequate training, a student may underperform compared to a well-taught one, regardless of natural talent. The same goes for machine learning. A simple model with lots of good data might do better than a more complicated one with less data. Adopting new teaching methods and tailoring styles to students can significantly enhance their performance. Similarly, in machine learning, models improve prediction and analysis as they encounter new data types and updated algorithms. This continuous learning and adaptation process is crucial to developing robust AI systems that can handle diverse challenges and evolve. Just as some students excel in problem-solving across various fields, certain ML models are better suited to specific ones. The data scientist needs to understand this and be able to use the appropriate ML model in a given situation. I hope this somewhat abstract example was helpful. Let's give a more practical example of how ML can help businesses. A real estate agent plans to develop a mobile app to provide prospective clients with an estimated selling price for their homes. Users can receive this estimate by answering targeted questions within the app. This could significantly boost the real estate agent's business by enabling them to collect contact details from people interested in selling their property. To put the plan in motion, the real estate agent contacted a data scientist and asked whether the project was feasible. The data scientist's first question regarded the availability of a sufficiently large list of past transactions. Fortunately, the real estate agent's company had access to a database with thousands of past transactions over the last few years. Later, the data scientist was pleased to find the data well organized, detailing house prices, sizes, room counts, bedroom numbers, distances from the city center, neighborhoods, and other fascinating aspects. "I can build an ML model with that," said the data scientist. Here's how the data scientist simplified the model for his client. You're familiar with the classic function notation where y is a function of x, right? Imagine we want to develop a machine learning model to predict house prices in our city by analyzing past real estate transactions in your training dataset. So, we have plenty of past transactions where both x and y are known. We need to train a machine learning algorithm with historical data to discover patterns and learn the best way to predict the future price of a home, y, based on the data from past transactions and the home's known characteristics. Clients enter their home's characteristics into the app. This forms input x. The ML model then generates output y, predicting the home's price based on similar historical data. This is where we'll end the story. Spoiler alert, the app was a huge success for the real estate agent's business. I hope this lesson clarified what machine learning is and how it works. In our next lesson, we'll discuss the different types of machine learning models. Thanks for watching.